Okay, so displacement is how far away from your starting point you are. So right here is the starting point. As I travel away from it, my displacement will be increasing. If I were to come back towards the starting point, my displacement would decrease. Velocity is how fast I'm traveling on this longboard, and it's measured in meters per second. And then acceleration is how fast my velocity is changing. And then friction is kind of like the particles like rubbing together, creating heat as a way to stop me. So I'm going to demonstrate all of those right now by going.
Potential energy is all of the energy he has right now. He is not moving a single bit, so he has that max potential energy. Kinetic energy is all the energy in motion. So once he starts going down the hill, he will start increasing kinetic energy. And now he's at max energy, max kinetic energy. As soon as he starts slowing down, he will gain more potential energy. And once he's completely stopped, he will have absolutely no kinetic energy. Newton's first law of motion is an object in motion stays in motion unless acts upon an outside force. The object in this case will be the Nerf bullet, and the outside force will be you.
Newton's second law states that mass is equal to force times acceleration. Both of these balls will be accelerated with the same rate, but they have different masses. So when we collide them together, the basketball will exert a bigger force on the bouncy ball, thus pushing it away. Talon will now demonstrate. Newton's third law states that for every action there's an equal and opposite reaction. So if I were to throw this ball against the wall, the ball will exert a force onto the wall, and the wall will exert the same force back in the opposite direction. So I can throw it like this, the ball hits the wall and bounces back. Newton's third law. Okay, so work is force in the direction of displacement. The ball is starting on the ground and I'm picking it up. The displacement is up and so is the force. So right there I just did work. And the momentum is mass and velocity. As the ball travels through the air, it's going to have momentum. And projectile motion is the path the ball will take in the air. It's kind of in an arc. So I'm going to demonstrate projectile motion and momentum at the same time right here as I throw this ball. You ready?
As you can see here, we have water in all three of its states. We have liquid, which is water, and it's boiling. That's so hot from the heat, it's becoming steam. As phase change, we have solid water, which is considered ice. We can watch the phase change by dumping into that, which actually cools down the hot water enough to eliminate some of the steam. As we can see now, the ice cubes are slowly decreasing and putting back to liquid form. The way we're getting this heated is through the oven, which is by conduction. The heating pad is heating the pan, and the pan is heating the water. And the water is getting so hot, it's becoming a gas state. And as we see now, the ice is pretty much gone.
Alright, let's get a little bit more into heat. So right here, we have all three methods of heat in one scene. So the heating element of the stove, it's glowing red right there, don't touch. It is directly in contact with the pan, heating up the pan and then heating up the water through conduction. Now the steam is rising, as we can see, it's creating a convection current. And then this is also induction heating because it's heating up my hand without directly touching the element, as like the water or the pan. So once more, we've got conduction, convection, and then induction all around it.
gravity is the thing keeping us to the Earth. Gravity is measured in meters per second. It is negative 9.8 meters per second squared. Like on this ball, you drop it, negative 9.8 meters per second squared. The sound it made is the energy that vibrates through the air and reaches our ear. That's what's causing the sound of the ball dropping.
Okay, so we're going to be demonstrating the different kinds of waves. Right here in the sink we have it full of water, as you can tell. We're going to demonstrate surface waves, which are a combination of transverse and longitudinal. So as I disturb the water, the waves will vibrate up and down and side to side, such as perpendicular and parallel to travel. And now if we go outside, we have Talon on the swinging chair, and he is also demonstrating longitudinal and transverse waves. He is bouncing up and down, creating compressions and rarefactions in the spring, and he is swinging the jump rope up and down, creating a transverse wave. And those are your waves, folks. It's dark in here. Electricity is described as the flow of electrons in a circuit. So a light switch works by creating a break in that circuit that can be controlled by the switch. Now as Talon turns on the light, it'll allow the flow of electrons to the light, creating light in this room. I get out of the bathroom.